The last practice task, number 8, and here we have quite a few different parts that we're going to create. So we need to get busy with it. We're going to drop making drawings for the individual parts. We're just going to 3D model them. We're going to concentrate on just getting the parts done and then assembling them and creating the assembly drawing. So we're going to drop the individual drawings. We've done enough repeats on those over the past practice tasks. So first off, I'm going to start up a new project. So go up to the projects folder. I start a new one. A new single user project. Find the correct folder on the H server. I create a new folder there. Practice task 8B. No, 8A. It was supposed to be. So I'll change the name of it. 8A. And also giving the project name as practice task 8A. And just like last time, we're going to create all of these parts in the same project. So this is the only project that we're creating with regard to this practice task. So then we'll start off with the first part. Yeah, preferably everyone is with. Preferably we'll have everyone with us on this. Yeah, if they feel confident in not following the lecture and doing other assignments, then that's completely fine. That's up to you guys on what you want to do. So we're going to start a new task. No, not a new task, a new part. And the first one we're going to create, we of course need to choose the metric folder and standard in millimeter IPT file. And the first one we're going to create is the shaft that's going into this valve house. And ideally I would have brought down some 3D printed models for you to see, but the ones I tried off didn't quite work with the threads on it, so it wasn't possible to actually screw them together. So I ended up breaking the shaft, so I don't have a 3D model to show. So I'll see if I can manage to print one before next week when we have the last part of this one. We'll start off with a sketch. And since we're creating a shaft this time, there are basically two ways of doing this. We can either create a sketch where we do the outline of the shaft seen from the side, and then we revolve the entire sketch. That is what I'm going to do here. But it is also possible to just sketch circles and extrude them and create the shaft that way. But since we have done very little revolves up until now, I'm going to show one of them. So we're going to create a sketch on one of the planes. Then I'm going to create a line. But I'm also going to mark the construction line option. I'm going to make the line horizontal and going across the center point of my coordinate system. And this line is supposed to be 283.5 millimeters long. So this is the axis of our shaft. Now I'm going to use the coincident constraint and figure out where the center point of my line is, and I'm going to attach that to the center of my coordinate system. So I go up to the coincident constraint. I go down here and I find the center point of my line. And I select the center point and then the center point of my coordinate system. So now it's just shifted the entire line over to the side until it was centered. And what I'm going to do now is to create half of the outline of this this shaft. So I'm going to create the top part of it, which means that I'm going to choose the line function again. But now I have to remember to remove the construction line, because now I want a continuous line instead. So I need to go over to the construction line option and click on that one so that it's not blue anymore. Then I'll start off in one of the ends of my axis line. And right now I'm just going to set, I'm not going to set any of the diameters right away. I'm just going to create the line up here. I'm going to set lengths as I go along, but I'm not going to set the diameters. I'm going to put those in with the dimension tool afterwards, just to show you a neat trick that you can have. So I'm just putting this line straight upwards for a little bit. Then I'm going to create a line that is parallel to the axis, and it's supposed to be 35 millimeters long. So we are starting in the thin end of this shaft. So 35 millimeters. Click my tab button to lock the 35 millimeters into place. Then I click enter. Then I'm going to have an even thicker part of the shaft. So I need to go straight up here for a little while. And then I'm going to set another length. And this length is going to be the total length. Let's see, 283.5. And of course, minus the 35 we just put into place. And then minus the other lengths that we have. So minus 36 and 34. Oops. And it's going to give me a total length of 178.5 millimeters on this one. Hit the enter button there. Now it's supposed to be a little bit wider again. And I can see I didn't get that one to be directly as it should. Here. To fix that one. There. I had to fix my line a little bit because it hasn't been placed in a horizontal position compared to my axis. It was slightly crooked, so I just needed to make it parallel. Then I'll continue from the end there. I'm going to make it a little bit thicker again. And then I'm going to have a length of 34. So I've locked it into place with a length of 34, and I press enter. And again, it's going to be a little bit wider. So a little more up there. We're going to zoom in a little bit here, because now I'm going to try to attach it to the end here. And now we've got 36 millimeters, and that's the last section that we have on this shaft. So I'm going to put it in there, and then I'm going to connect it to the axis line down here. So I'm just going to zoom out so everyone can see a little bit here. So we have the first part was 35 millimeters. The second part was 178.5. The third part was 34 millimeters. And the last part is 36 once you attach it directly to the end of the axis. We haven't set the height yet, so we're just putting in random heights right now, because I'm going to show a pretty nice trick of setting diameters here instead of heights. $36. Then we'll start looking at the different diameters that we're supposed to have on this shaft. And we have to remember that the construction line we created here, that's supposed to be the axis that's going through the center of our shaft. So then we go up to the dimension point here, general dimension. And we're going to set the dimension from the axis and up to the first line here. But before we place the dimension, we're going to right click. And we're going to choose this option here, linear diameter instead. Because now I can set the actual diameter of this one, because it's using the first line I pressed as the center of my diameter, and it's putting it across here. So now I can actually go into my drawing and see exactly what the diameter was supposed to be. I don't need to do the diameter and divide by 2 to do this length. I'm just putting it directly in here. And for the first part here, it's supposed to be a threaded part, and it's supposed to be M14, which is metric threads, with a 14 millimeter diameter. So we put in, I have to place it first, and then I put in 14. That's going to give me the correct diameter here. And you can see from the dimension that it's actually showing it from a imaginative spot on the other side of the axis. So we can continue doing the same with dimensions on the other ones. So I'll show it slowly on the next one here also. So first I click the axis line. Then I click this one up here. And before I place the dimension, I right click with my mouse pointer and choose linear diameter instead. And this one is supposed to be also threaded at the end, so it's going to be M20. That means it has a 20 millimeter diameter. So we put in 20 there. And this one also goes to the imaginary point on the other side of my axis. So I do the same for the last two parts here. Right click and choose linear diameter. Place it. And this one is going to be 2 millimeters thicker on each side. So it's going to be 20 millimeters plus 2 plus 2. So it's going to be 24 millimeters in diameter. That's because we're going to put a chamfer, 2 millimeter chamfer on the edge there once we've finished revolving this one. Then we'll do the last diameter here. I'll zoom a little bit in here. I click on the axis, on the horizontal line, right click, linear diameter, then I place it, and this one is supposed to be 42 millimeters in diameter. So I'll zoom out a bit so that we can see everything. Doing these dimensions in diameters isn't really necessary. You could have put in the diameter and divide by 2, just giving the length from the axis. Wouldn't have been a problem at all. But it makes it a bit more easy to visualize it from your sketch, how this is going to look. And it also makes it quite a lot easier if a colleague of yours later on is going to come in here and do some changes to this 3D model. Then they will very easily see what is what in their in the sketch of the 3D model, so that they can easily change stuff. So now we're going to click Finish Sketch. We can see that we have everything fully constrained down in the corner here. So I click Finish Sketch there. I'm going to zoom out a bit so that we can see everything here. And now we're going to use the revolve function, which we haven't used before. I think we haven't used it before, at least. Can't remember. The revolve one is beside extrude, and it basically does the same thing as extrude, but extrude takes the outline from the sketch and it pulls it in one direction, while revolve instead rotates it around an axis, so that it basically looks sort of similar to turning a workpiece in a lathe, so that you're actually more similar to how it's going to be machined if you're doing the revolve stuff here. So we click on revolve. I'm going to drop down the menu in the window there, just to show it a little bit better. So first off, we need to choose a profile, and the profile has been chosen. Looks like it. And then we need to choose our axis, which is the construction line from our sketch. And now we can see a preview of how it's going to look once it's been revolved around that axis. You also have the possibility, if you want to not have it be revolved a full circle. That's up in Extents there. It is possible to set a specific angle. For example, if I put a 90-degree angle here, it's only going to revolve it 90 degrees. It's not going to do the rest. But of course, we want this to be a actual shaft, so we're going to have a full revolution, full 360 degrees in order to get everything in here. Then we click OK. And I did something wrong there. Let's see. Yes, I hit the wrong one here. Let's see. I didn't want to do that. Jeg skal ikke ha noe å si det. Ah, yes, my apologies. I see I have done something wrong here. It's not supposed to be a construction line. I was a bit too quick. It's supposed to be the one below it. So you see, when I mark the axis in my sketch, so I've double-clicked the sketch over in the browser window. And when I then mark the construction line, you can see that it's blue up there with construction. It's not supposed to be construction, it's supposed to be the one below it, which says a center line, of course. And then you can actually see that it's changing shape to look like a center line also. That was my mistake there. So once that has been changed into a center line instead of a construction line, then the revolve is going to function properly. It even chooses everything for you directly. Right, then I'm going to set the revolution in place here. So now I've got this shaft that's been turned in a machine, basically. We've created this, but we need to do some more with it. We're going to have threads over here, and we're also going to have a chamfer on some of the edges over here. So we need to start looking at that. So I think we'll start off in this end, and we'll look at the chamfers first, and then we'll do the threads afterwards. And for this particular part, we're going to start making the drawing, just so that I can show you how to put dimensions on threads when we're using it, because we haven't done that yet. So we'll start off now by doing the chamfers here, because then we're done in this end and we can concentrate on the threads afterwards. So I go to the chamfer option up here. And on the edge here, we're supposed to have a certain diameter here and a certain length in. So we can't use the regular one with 45 degrees that we usually use. We have to use another one. We have to use the third option here, which is 2 distances. And then I'm going to click on the edge here. And then I'm going to zoom in a bit, just so that we can see the arrows here. So now we can see the orange arrow is pointing towards the center here. So that's going to be the diameter measurement that we need to set. So when I'm in this one, that arrow is orange. If I switch to the other measurement here, it also switches which arrow is orange, as you can see there. So for the first one here, that's going to give us the diameter we need. And the diameter is supposed to be 35.5. So I'm going to put in 35.5. Whoops, need to remove the millimeters. But as you can see, this doesn't work. I'm getting an error message here. 35.5, that's way too much. Because that's, of course, the entire diameter that we're supposed to have. And we're talking about a radius here. So I divide it by 2. But that's not quite correct either. So we need to go for this being subtracted from the total diameter of this one. So we need to have a minus in front of there. Do you remember what the total diameter was? It was 42 millimeters. So we do 42 minus 35.5. But now we need to put those two in a parenthesis so that we get both of them divided by 2. So this is going to give us the difference from the outside and into where we are supposed to be. So we have given 2 diameters. That's why we need to divide by 2 in order to get the radius instead of diameter. And we've done the external diameter minus the internal diameter. So we get a difference between those 2. Then we can move over to the other one, which is going to give us the length along the axis that it's supposed to go. And this one is supposed to be 10 millimeters. So now we can see that it doesn't look at all like the regular 45 degrees chamfers that we usually put in. But this is because it's supposed to fit inside something and have a complete seal against it. So now we can place this one. Click OK. So that one is in place. The next chamfer that we're going to place is along this edge, and that one is a regular 45 degree chamfer of 2 millimeters. So we go in for our chamfer, we switch back to the top option there, which is the 45 degrees, and we switch the distance to be 2 millimeters. And then we select the edge there. I'm going to switch my model around so that we can see it properly. So there we have a 45 degree chamfer on that one. So I think we'll do a short break before we do the threads on this one. Right, then we're back from the break. We're going to start putting threads on our shaft here. So then we're going to use the thread function that we have up top here. So it's the one up here that says threads. So we're going to click that one. And then when we move it across a part of the shaft, it's going to preview some threads there for us. So if I select this part of the shaft, we can see that it's put an image of threads on top of the shaft there. And in this case, on the end here, we're going to have full length. So we're going to keep this one checked, because we want the entire length of that tip to be threaded. We also need to have a look at the specifications. And we go down to using an isometric profile. Those are standard metric threads that are being used. And the first one that Inventor chooses for you is the one with coarse threads. So it's the one with a pitch of 2 millimeters. But in this case, if we look at our drawing, we're supposed to have 1.5 millimeters pitch on our threads. So we need to change it to M14 times 1.5. Now usually when you're designating threads, if you're going to use the coarse one, which was a 2 millimeter pitch in this case, then you will only write M14. You won't write M14 times 2. You'll only write M14. But if you have smaller pitch than that, which means that you have finer threads, then you write the times 1.5 or 1.25 or whatever pitch it is that you have on it. And you can also see that Inventor has automatically chosen 14 millimeter threads for us, because we have a 14 millimeter diameter on this part of our shaft. So it's sort of automatically chosen for us. We can't, if we try to change it to 27 millimeter M27 instead, it's not going to work. Inventor is going to tell us this doesn't match, so I can't use it anyway. So we're going to click apply. So then we have threads put on here. And there's one thing we need to note with this one. The threads that we can see here on our shaft, that's just an image placed on top of a cylinder. So the threads haven't actually been modeled in there. So that if we are going to 3D print this one, it's not going to work. So then we're not going to get any threads, it's just going to be a cylinder there. Because the 3D printer doesn't know that image at all, it just sees a cylinder. So if we're actually going to use a 3D printer to get this out, we're going to have to manually create threads. So we're going to have to start cutting the threads out in a spiral pattern. When you use a spiral pattern, you use the coil function up there. But this is not something that is necessary to do unless you are actually going to 3D print them. So that's what I had to do when I was 3D printing them. Unfortunately, I tried using some shortcuts with an app that works along with Inventor, but it didn't model them correctly. So I had a full crash on my threads, which meant that when I tried to tighten them in, then I just broke the parts instead. But if I had gone in and modeled them by hand, I would have been able to print them and have them work afterwards. So you would have to use the coil function then, and it starts getting really complicated when you start doing that, which is why using the thread function is so much easier. Because when you're creating stuff like this, you're most likely not going to 3D print it. Maybe you're going to 3D print a prototype or something, but most likely you're going to have someone machine it, and they only need this image information that's placed on top of it. 1,5. So then we're supposed to have some threads going up here also, but on this part of the shaft we're only going to have the threads going 95 millimeters up the shaft, not all the way to the end. So we have to use the thread function again. We'll select this larger diameter, and you can see again with the full length is the one that's chosen now, so it's trying to put threads all the way up for us. So I'm just going to select it first, and then I'm going to remove the check mark on full length. And here we can see that he's putting it over on this end. I don't want that. So then I need to reset the threads. And now we can see that it's putting it on this end. My problem was with the first one, I had my mouse pointer too close to this end, so it shows that as my starting points. So if I move my mouse pointer over here now, it also moves the threads over here. So I'll move it back here, select it again, and I have, it says 10 millimeters now, it's supposed to be 95, so we need to change it to 95 millimeters. There is also a possibility of using an offset. So if you want threads, but you want them to be, for some reason, in the middle of the shaft, you can actually use the offset, for example 50 there. Then I've moved the threads into the middle of the shaft. Might be necessary if you're going to have some cog wheels or something that's going to be rotating here and then pushing the rod along. That might be necessary to do then. But for usually when you're using threads, it's in order to put a nut on, screw a nut onto them. So then you want them all the way to the end, or else you're not going to reach the threads with them. So we want 0 there. Again, we'll go over to the specification. We can see that Inventor wants us to use ANSI, which is an American standard. But we want the ISO one, which is the European one, with the metric profile. And on this one, we're also supposed to have a pitch of 1.5. So we change the designation, and we go down to 1.5. And you can also see it says right hand and left hand there. And maybe you can remember, I talked a little bit about it in subsea technology, I think, with regards to which way you are tightening and loosening your nut. So right hand is the usual one. When you are rotating it clockwise, it's going to be tightened, and rotating it anti-clockwise, it's going to be loosened. But if for some reason, if this is a rotating shaft and you need your threads to go the other way around so that it won't loosen itself while it's rotating, then you would choose left hand instead, because then you're telling it to go the other way. But so long as you don't have a particular reason for using the left hand, we always use right hand. So we click OK there. So then our shaft is done. And we'll go into creating the drawing for this one, just very briefly, just so that I can show the dimensions for these two parts with threads. So I'll save this one, and this will be shaft. Save. And then I'm going to create a new drawing, iso.idw as usual. Click create there. I'm just putting in my base view here. Have it on a scale of 1 to 1. Click OK. So what we can see now, it looks a little bit different here, and that's because we have threads there. So I'm just going to zoom in a little bit to show you better. So here we can actually see that the threads are being designated by a thinner line going on the inside there, and that's to show the smallest diameter in the thread cross section. So what we do when we need to show the dimension of threads is that we go over to the annotate part, and we use the hole and thread function. And instead of pointing it to a hole, as we've done earlier with the hole and thread function, we're going to click the edges of the threads here. So the top edge. We could just set it like this. Let's see, switch it to method 1B here. We could just set it like this with an arrow pointing to it, but it is usually a bit easier to read it if we go to the other side and click on that one also, so that we get it more as a diameter measurement for it. So putting dimensions on threads is fairly easy. We just use the hole and thread function instead of a regular dimension for setting a diameter, because then it's going to give us all the information we need with regards to these threads. I'll just save this one so I have it. The next part in the compendium is a bolt, and if you follow what's being done in the compendium, it basically shows you how to do the revolve function also to actually model the threads three-dimensionally. What we're going to do instead is to do the shortcut where we are pulling pre-made bolts from the library when we're doing our assembly, because that is the normal way of doing it when you're doing assemblies. You just pull standardized bolts and nuts to use. So we're going to just jump straight past the bolts and nuts here until we get to part 5 in this practice task, the valve flange. And now we're going to start on that one. So we're going to open a new part file, standard in millimeters. Then I'll start a new sketch, and this one is looks basically like you can draw it up here. Here we have the basic view of it. So this is the top of the valve that we're going to create, where our shaft is going to go through this one. So we'll start off by making the base of this valve flange, so the flange part itself. So we'll start a new sketch. And the base is circular, so we'll start off by creating a circle. We attach it to the center point in our coordinate system. And it's supposed to be 125 millimeters in diameter. So I type in 125. I use the tab button to lock it into place. And then I click OK. Then I finish sketch. And I'm going to extrude it. We're going to create a couple of holes in it later on, but for now we're just going to extrude it as a circular plate. The thickness is supposed to be 17 millimeters. And now we're going to create a sketch on top of this circular disc. And now we're going to create the the sort of box that's going to be protruding out of the disc. So we need to put in a rectangle, but we want the rectangle to be centered in our coordinate system. So we'll use the drop-down menu, and we'll choose the rectangle option where we are allowed to define the center point. And then it's going to be 60 millimeters wide. Use the tab button to go to the other dimension. And it's going to be 40 millimeters thick. And again the tab button to lock the dimension into place. And then I click enter. Then I can finish the sketch. And I can extrude this one. And it's supposed to be 80 millimeters tall. So now we have a circular disc with a square box on top of it, or a rectangular box on top of it. The next step that we're going to do is to hollow out this box. So we're going to create a sketch on the largest side of it, so the one that is 60 wide. So we'll create another sketch on here. Just going to zoom it in a bit here. And just to make life a bit easier, we're going to project geometry so that we can attach our sketch to the edges here. So that we get these yellow lines showing everything. And one thing that we can do also now, because where we have the plane in which we have our sketch now is not the same plane as the edge of our circular disc. So the circular disc is actually sticking out of our sketch right now. So one thing we can do is to press the F7 button on the keyboard. And it's going to show our 3D model as cut instead. So if we were supposed to model something into the disk here, it will make it easier for us to see exactly what we're doing. If you press F7 once more, it's going to pop back again to look like this. So it's not really a big problem in our case right now, because we're only going to model on the flat surface there. But as soon as you're going to model something that's being hidden by something else, it's nice to use the F7 option in order to be able to see what you're doing in the sketch. So I'll just leave it visible like this while we're doing it. So this time we're going to create a new rectangle, but I'm just going to create a regular one where I'm setting 2 corners, because I'm going to set the dimensions afterwards. And I'm just going to place it fairly randomly inside here. And then we're going to set the distances to the edges. So we go up to dimension constraints. And we're supposed to have 10 millimeters to the edge. So 10 millimeters up top there. Then I can do the same for the sides. And in case I need to change this dimension later on, I'm going to connect it to the top one so that I only need to change one of them to change all. So I'm just going to click on the top one and place it. I'm doing the same down here, clicking on the top one and placing it. And the same over here, clicking on the top one and placing it. So if I change the top dimension now to 12 millimeters, then all of them are going to change to 12 millimeters. Once that is done, we finish the sketch. And we're going to use the extrude function to make a cut through the box here. And since we put in the yellow lines, Inventor doesn't quite know right now what outline it's supposed to do. Is it supposed to do the small rectangle or the large rectangle? Doesn't quite know, so we have to tell Inventor that we want the center rectangle there to be extruded. And the default from Inventor is to extrude it and create more material, but we want it to be cut. So we'll go over to the cutting function there. And in this case, we could let it just stay 80 on distance, or we can do all there, because then it's going to cut through all of the material no matter what. So if I rotate my 3D model a little bit now, we can see that it's possible to see straight through it. So we've created a hole straight through it. The next thing we'll do is to create fillets for all of the edges of our square box. So we're going to have 5 millimeter radius fillets on everything. So I'm just going to rotate it back here. I'll go up to the fillet function. And we want 5 millimeter radius. And then we just need to start clicking on all of the edges here on the box. So I'll start up top. So I've done the outer edges of the top there. I'm going to do the sides, the outer sides. And I also need to do the cutout inside here. So I need to do these edges. And now I need to rotate it because there is a couple of edges that I haven't clicked yet that are over on the other side. So I'm going to rotate it 180 degrees. And then I'm going to continue clicking on edges here. So now I've done the outer edges of the box itself, and I've done the openings of the cutout, but there is still some fillet edges I haven't selected yet, and that's the inner edges. Those are also supposed to be 5 millimeters. So I need to select that edge, and I need to tilt it a little bit so that I can do this edge up here easily. Tilt it over here to get this edge, and tilt it back down here to get this edge. So now I've actually marked all of the edges of this one. The only edges I haven't marked are the ones that are connected to the circular disc, but those aren't supposed to be filleted. So then I place it. You can use control and click on an edge to deselect it, yeah. Hmm? Yeah. Yeah, carry on. Yeah, if you hold down your control button and then click on one of the ones that you have already selected, then you will deselect it. If you can't get control to work, you might try with shift, but it should go, should work with the control button. The next step is to start making holes in this one, because the circular disc is supposed to be a flange, so we're going to have 4 holes in it for bolts to go through. And we also need a hole going through the middle here for the shaft. And for the hole going through the middle, up top here we need a clearance hole, so that we're going to get the threaded part of the shaft all the way through. And then we're going to put a threaded hole in the middle in order to be able to actually rotate the shaft and screw it in and out. So we'll start off with the hole up top here. So I'll use the hole function. I'm going to select the surface up top there. I'm just going to zoom it in a little bit so that it's easier for you guys to see. And now I need to click on some edges to give references. And we'll try to hit the edge of the fillet here, because we know that from the edge of the fillet and to the other side of the fillet we have 40 millimeters, so we can then set 20 in order to get it to the middle. So we click on that edge and we set 40 divided by 2, or 20 directly. What's going on here? 40 divided by 2. It's doing it, it refuses to choose the fillet edge. That means we need to do 30 divided by 2. So the reference is this edge instead. We've done a 5 millimeter radius on both sides, so that means that our surface up top here is 30 millimeters instead of 40. So we need to put that into account when we are putting this one in. The other reference point will be on the other side here. And we have 60 all the way across, but we need to remove 10 because of the R5 fillets. So 50 divided by 2. Divided by 2 there in order to get it in the middle. And we are supposed to have threads going through here. So we want the threads to be able to pass through this hole without touching the edges. And if we put a regular hole there with a 20 millimeter diameter, we risk collision between our threads and the edges of the hole. So what we're going to do, instead of placing a regular hole, we're going to place the next option, which is a clearance hole. So we're going to get some more information that we can fill in here. And the part of the shaft that's going to go through this hole, that's going to be the M20 part. So we're going to have M20 threads going through here, which means that we're going to choose not ANSI unified screw threads, we're going to choose ISO up there. We're not going to have a countersunk flathead either. We're going to have a hexagonal head cap screw. And we're going to set the size of it, which is M20 over here. And then we have the bottom one here, which is the type of fit that we want. Basically, how much clearance do we want to have on this one? So in this case, we want a close fit for it. Jo, det friholder jeg settet. Nei. The clearance hole, you specify what kinds of threads are going through the clearance hole, and then you specify if it's going to be close or normal or loose. That's going to set what diameter the hole is compared to the threads. So as you can see up here now, it's automatically set it to 21 millimeters. We have 20 millimeters threads that are going through it, and we have a close fit, so we're going to have as little clearance as possible, but there's still going to be some clearance, and that means that we will have 1 millimeter extra radius on our hole. If I had put it on loose, the hole would be 24 millimeters, and we would have quite a lot of clearance to our shaft. But we want it to be close on this one. Once that is done, we need to make sure that we're not creating the hole all the way through like we're doing here, because down here we want threads on our hole. So we're going to change the termination, as it's called here. And we're going to use the 2 option. And that means that, let's see, I'm just going to move this one over here. So if I change my view a little bit, rotate it around here, the 2 option means that I can click on a surface and it's going to create a hole to that surface. So if I click on the surface that is underneath here, a little bit closer here, so I click on the surface underneath there, and it's only going to create the hole through the top part. If I now click on OK, I can rotate it back, then we see we only have the clearance hole on the top. We don't have it going all the way through. You select the surface underneath there. So gjorde det selv. Han gjorde det selv. mening att vi ska vara. See. There, we've gotten the shaded with lines back. It was, for some reason, Inventor did it itself when I put the hole through the top. So. The next thing we'll do is to create the threaded hole in the middle. So we'll just flip the part so that we can see the underside of it. And now when I flipped the part, the edges were removed once again. So I don't quite know why Inventor is doing that, but it's not really a problem because we don't really need them. So we're going to use the hole function again. And this time we can use the concentric one because we're going to have a hole in the middle of the circular disc. So that's why instead of creating it inside the square box, I am creating it from the underside instead, because then I can use the concentric reference. So click on the underside there, select that surface, and then I select the cylindrical edge of the disc. Then it's going to place it in the middle. This time, we're not going to have a clearance hole. We're going to have a threaded hole. So we're going to click on this one, which is going to give us threads. And we need to select our thread type, the isometric profile. And we don't want 22 as our size, we want 20 as our size. And if we remember from the shaft, we had a pitch of 1.5 instead of the 2.5, which is the coarse one. So we need to switch it to 1.5 there. And we want the threads to be along the entire depth of the hole that we're creating. So we're putting full depth in there. And in this case, we can actually make our hole through all, because the clearance hole up top here is larger than the threads that we're using. So it's just going to pass through the middle of the hole and it's not going to touch the edges. Once we click OK, we get the hole in the middle here, and we can see that it's put the image of threads inside the cylinder there. And Inventor has fixed all of our dimensions there. I'll tilt it around so that we can actually see the hole up top here also. We'll try to get the 4 flange holes also in place before we do a break. And then we're going to place a sketch on top of the flange part that we have here, the circular disc. And we're going to place 4 points and then use the hole function to create holes on top of those points. So I'm going to click on the top there. And even though this part in the middle isn't really obstructing our view of anything, we still have the option of using the F7 button in order to just see the circular disc in this case, if we want to. So then I'll place a point up here. And I'll try to place it above the center here, like that. I'm going to give it the dimension from center to point. And we're supposed to have 52.1 millimeters up to that hole from the center there. but I also want to make sure that it's going to stay directly above. So I'm going to lock it into place with a horizontal constraint. So I'm using this one up here, horizontal constraint, and I'm clicking both on my point there and on the center point, because that means that I can't move my point sideways. It has to stay a vertical constraint. I'm using the wrong words here. It has to stay vertical with regards to the center point. So it has to stay right above or right below. So I can only move it up and down. But I've already set the dimension from the center point, so now it's completely locked. So that's why it's dark blue in this case. And then we can either use a circular pattern in here in the sketch and create four points, or we can exit the sketch, create one hole, and then use a circular pattern on that one hole to create all four. It doesn't really matter. I'm just going to use the circular pattern in here. So circular pattern, choosing the geometry, and that's only the point. Then I go over to the axis and I choose the center point of my sketch. And straight off it wants to place 6 points, but I only need 4. So I change it to 4. And then I get 4 points that are evenly spaced. So they're all at a 90-degree angle. So then I click OK. So I'll just show the circular pattern once more. I hear there's a couple of questions on it. So I go for the circular pattern up top there. And first it's asking me for what geometry am I going to put in a circular pattern. And that's my point. That's the point in itself. I'm going to create a circular pattern just from that one point. And then it's asking me to give it a rotational axis, which just means I need to give it a point that it's going to rotate this across. So I click on the axis one there, and I go down to the center point of my sketch, and I mark that one. And now it's revolving it around this one, and it's trying to place 6 points at first, but I only need 4, so I change the amount to 4. And click OK. Once those 4 points are in place, we'll click Finish Sketch. And we'll go back to the hole function. But this time we're not going to create threaded holes. We're going back to the clearance hole because we are going to have M12 bolts going through these holes, holding the flange in place. So we're going for clearance. We still want isometric threads. We're still going to use hexagonal head cap screws, but the size now is supposed to be M12. And we're still going to use a close fit for it. And then you can see we have a 13mm hole for the 12mm bolts. And these 4 holes are supposed to go all the way through the flange. So we click OK. And then we have them in place. Hex head. M12. Yeah. We'll do a break, and then right after the break, I'm going to quickly show how we put the dimensions on a clearance hole, just to have that shown in a drawing also.